I am Anil Kumar. Let me first thank all the viewers and subscribers for my YouTube channel to watch these videos. I'm very grateful to so many subscribers and I'm really happy to see how actively you have been participating. Many students have been asking questions and we have been providing free solutions on this channel. We do have another WhatsApp group which is called Free Math WhatsApp group, where again many professionals have joined my hands to provide solutions to questions provided by the students. Now, this question comes from one of our subscribers who wants to understand how to find the equation of a polynomial when some conditions are given to us. It is based on calculus. We'll be using the derivatives, the application of derivatives to solve this particular question. Well, in case you want to learn from me, you can always send an email to the address given here. You can also visit our website, Global Math Institute, to learn what are we putting up there. Many of the course curriculums are being developed for students worldwide, and excellent quality of material will soon be there. Some is already being posted. Now, the question here is from one of our students, as I said, and the question is very interesting. It says, make the cubic function f of x equals to ax cubed plus bx squared plus cx plus d tangent to the line y equals to 2x plus 13 at a equals to minus 1, 1 and have a horizontal tangent at the point b, 1, 5. I would like you to pause the video, answer this question, and then look into my suggestions. Now, when you get such a question, you have to think what should be the strategy. So, we'll begin with the strategy of the solution. We need to find what? We need to find four parameters here, right? We need to find what A is, what B is, C, and D. To find the four parameters, what we need is four different equations. So, how do we get these four different equations? That is what you have to figure out. Well, clearly, what we are given here are definitely 2 points, right? So, these are the 2 points where we have tangents, right, on the curve. So that means these points are on the curve. These 2 points will give us two equations. So we'll begin with the equation of the function itself, which is f of x equals to ax cubed plus bx squared plus cx plus d. Now, using one of the points, we get our first equation. Point A is given to us as minus 1, 1. When we substitute minus 1 here, we should get 1 as the output. Substituting minus 1 for x gives us the relation, which is minus a plus b minus c plus d equals to 1. We'll call this as our equation number 1. Now, second equation we are going to get by using point B. So point B is 1, 5. Replace x with 1 and y with 5, right? So you get the second equation, which is a plus b plus c plus d is equal to 5. Now, from these two equations, clearly, you see a very interesting thing. That is, that we could eliminate many of them. By adding these two equations, we get 2b plus 2d equals to 6, which can be simplified as b plus d equals to 3. Right? So we get this another interesting equation. So we now have two equations from where we came up with an equation which relates only two parameters. B plus D equals to 3. Now, how do we get the third and fourth equation? Well, for that, let's look into the concept of tangents. So we are saying tangent to the line y equals to 2x plus 13. It really means that at the point minus 1, 1, that means at x equals to minus 1, the derivative of the function, which represents the tangent, should be slope of the line, right? So that should be equal to 12. Is that clear to you? So that should give us the third equation. So that means let's find the derivative of the function. So we found the derivative of the function using the power rule. So we use the power rule to find the derivative. Simple as that. Ax cubed gives us 3ax squared, bx squared gives us 2bx, cx will derivative is c, constant d has a derivative of 0. So we have eliminated d from this particular equation. Now, as far as the derivative goes, we are given derivatives at two different points. One, of course, at x equals to minus 1, and then we also have a derivative at point B, which is it has a horizontal tangent line at the point B. That means somewhere we have a turning point, correct, where the slope is 0. So we also know that the derivative of this function is 0 at a point which is given to us as x equals to 1. Correct. So at this point, when I substitute x equals to 1, we know the point is 1, 5, right? So we could use this particular find here and get our fourth equation, correct? So now, when we have the derivative, we're going to substitute the value of x as minus 1 for the first point and equate that derivative to 12. And then we can also substitute x equals to 1 and equate that derivative to 0. So we have two more equations. I'm calling them equation 4 and 5. Now in these two equations, you can see that the terms 3a, 3a and c will cancel away when I take away equation 5 from equation 4. Clear? So we could simplify this and we have 4b equals to minus 12. That gives us the value for b. So one of the parameters, b, is known to us as equal to 3 minus. So this minus 3 is known to us. We already had an equation which related b and d. So now we can find what d is, right? So d is 3 minus b. Substituting minus 3, we get 3. Minus minus becomes plus. So 3 plus 3 is 6. So we get the equation's second parameter, which is d. So we know the values of b and d. Now we can use our equations with these two known values and then eliminate and find the other two parameters. That's what we did. So now let's get back to our equations once again and see how we can manipulate them to find the value. Well, last time we subtracted. Now this time, let us add them. When we add them, we eliminate 2b, 2b. And we get an equation in terms of a and c, right? So we get our equation in terms of a and c, which is 6a plus 2c equals to 12. Now dividing by 2, we get 3a plus c equals to 6. And now we can write c in terms of a. So we know c in terms of a. Now we know b and d, and we know c in terms of a. Substituting these values in any one of our equations, we selected equation number 1, the very first one. We substituted the value of a. B we substituted as known to us, which is minus 3, and the value of c we substituted by 6 minus 3a. So we got an equation in terms of a that helped us to find the value of a, which comes to 2. So we have a as 2. Substituting that a when the equation c equals to 6 minus 3, we know the value of c is, in this case, 0. So we know all our parameters. We get a is 2, b is minus 3, c is 0, d is 6. And that's all. We could get our equation. Well, we sketched the graph just to verify the result, right? Now you could see from graph very clearly that the point B has the horizontal tangent, and this point is 1, 5. The point A, which is minus 1, 1, where the equation of that line given to us, 12x plus 3, is tangent. That means our solution is perfectly fine. I hope you understand and appreciate the strategies applied to solve such a question. Very interesting question to begin with. So in calculus, you will definitely get a question like this right in the very beginning. So I hope that gives you a good start. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that would be great. Also, join our WhatsApp group to really understand how amazing solutions can be provided in no time with some professionals who have dedicated themselves and volunteered for providing you with the much needed help. Feel free to contact us. I will also provide the link for our WhatsApp group with which you can join the group also. Thanks for your time and all the best.